For this video, we're going to write a equation of an ellipse given characteristics. So our first section, we're going to go over vertices and foci. So in this example, our vertex is 16, -4 and 2, -4. Our foci is 9 plus square root 13, -4 and 9 minus square root 13, -4. So as you look at your vertices and our foci, the only thing that repeats is -4. So from there, automatically, you can say that K is -4 because it repeated in both vertices and it repeated both in foci. So you could safely say that K is -4. Now looking at in our vertices, K is the same and foci, K is the same. The only form that we have to use according to the formulas where K stays the same is when the a squared is underneath x minus h squared. So what we're going to do is we're going to follow the formulas according to this standard form. The square of x minus h over a squared plus the square of y minus k over b squared equals 1. So again, we're going to follow the formulas for this one. So in order to find the values of h, a, and b, we have to use the foci here. Now the reason we're going to use that is because according to the formulas for foci, for this standard form, the first one here, which I'm going to make a star, the formula for foci according to the, again, to the standard form here is h plus and minus c comma k, but we're only going to focus on h plus minus c. So h plus c, well, that's the same as this one right here, 9 plus the square root of 13. H minus c, which is 9 minus square root 13. So you see how the h's repeat, the 9's repeat. So therefore, from here, h is 9. And my c's right here. So c is square root 13. Alright, so now how is that going to help us find the values for A and B? Well, going back to your 7.2b notes, video notes, there was a chart where it tells you the relationship between c squared, a squared, and b squared, which was c squared equals to a squared minus b squared. Now, how could we find the values of a and b if we don't know both of them? Well then, what we're going to do next is that now we're going to use, we have foci, now we're going to use the information from vertices. Alright, so I'm going to erase to make room. And then let me write out the values of h, which is 9, and the value of c, which is the square root of 13. Now, according to the formulas for vertices, with this standard form, which is h plus and minus a comma k, but we're only going to focus on h plus minus a because the k's are the same. So what it means is that h plus a equal and h minus a equal. Now for the h plus a, usually we're going to use it with the bigger number, so here, which is 16, and then h minus a we're going to use with a smaller number, which is 2. So I use the 16 from this vertex, and I use this 2 from that vertex. Now, within this system of the equation, we don't need to find h, we need to find the value of a. But here's the situation. The first a is positive and the second one is negative. If we were to solve system of equations with the elimination method, then that means that the a's would cancel out and we did not solve for a. So what we can do for the elimination method, we can change either both of them to negative or both of them to positive. So what I'm going to do is I'm going to change this a minus a into a positive. So I'm going to multiply the whole equation by -1. So it's going to become negative h plus a equal to -2. So again, I multiply -1 to the whole thing. Next, I'm going to combine with the original first equation, h plus a equal to 16. So with this system of equation, doing the elimination method, the h will cancel out because h minus h will become 0. But here, 1a plus 1a, that's going to become 2a. A positive 16 with a negative 2, that's going to become 14. Divide by 2. So my a is 7. So I'm going to write here a equal to 7. Next, I'm going to erase to make more room. Alright, now we're going to use this formula. Alright, so I'm going to plug in the value of c, which is square root of 13 with the square, equal, I'm plugging in the value of a, which is 7 with the square, and then minus b squared. So all we're going to do is just square both parts. So the square of square root of 13 is simply 13. The square of 7, that would be 49, minus b squared. So what I'm going to do next is I'm going to subtract 49 to get b squared by itself. So 13 minus 49, that's going to become negative 36, equal to negative b squared. But we need a positive b squared, so I'm going to divide by -1, divide by -1. So therefore, b squared is 36. Now, we don't actually have to solve for the value of b, because what we need to do is, when we plug in, is asking for b squared, so we don't need that. So I'm going to write right here, b squared equals to 36. Now, for the standard form, all we have to do is just plug in the values for h, k, a squared, and b squared. Now, a is 7, but we already found the value of a squared, so we just square it. So a squared is 49. So, again, I'm just going to plug in the values with the a squared underneath x minus h. So it's going to be x, my h is 9, so it's going to be minus 9 with the square, over my a squared is 49, plus, now it's going to be y. So since my k is -4, this will become plus 4 with the square. So again, y plus 4 squared over my b squared, which is 36, equal to 1. So that will be our final answer. X, the square of x minus 9 over 49, plus the square of y plus 4 over 36 equal to 1. So here is our final answer.